For more than a decade, the SOHO mission has provided great insights into our sun, its dark spots, massive flares, and the quakes on the surface which betray the inner composition. Astronomers have been eager to extend its pioneering techniques to other stars. The corot spacecraft, standing for convection rotation and planetary transits, will learn much more about the interior of stars, and it will be breaking new ground in the search for distant worlds outside our solar system. Since the discovery in 1995 of the first extrasolar planet, more than 200 have been identified using ground-based telescopes.
The planets that we've found so far are gas giants, more akin to Jupiter in our system. Corot is the first space mission, and the first mission ever, that is looking for planets like our own Earth.
The 360-kilogram satellite, launched by a Soyuz rocket from the Baikonur Cosmodrome, will be placed in a polar orbit at an altitude of some 850 kilometers. It carries a telescope with a 30-centimeter primary mirror focusing on a two-part camera, and will alternately observe opposite regions of the sky, starting with the Orion constellation.
We will remain on this target until we have been traveling around the Sun together with the Earth, so that the sunlight starts penetrating into the telescope. After that, we will turn 180 degrees and look in exactly the opposite direction, towards the direction of the galactic center, as it were, and continue observing there for 150 days. And we will continue and do this, building up a stellar catalogue of hundreds of thousands of stars that we will have observed, where we hopefully will find lots of nice planets.
The telescope will not see planets directly. Their presence will be indicated by the very short and slight drops in the luminosity of a star as they pass in front of it. During its 2.5-year mission, Corot will certainly discover many dozens of new gas giants, but identifying the very first rocky planet other than our own will have big implications.
If we find one more in the vicinity of the solar system, because Corot is not looking that far away, then that implies, given the immensity of the galaxy and the number of stars, the 400 billion stars that we know about existing in our galaxy, that there must be a lot of them.
Led by the French space agency CNES, the mission today has a wide-ranging European scientific and technology participation, with the European Space Agency contributing essential parts of the spacecraft, the telescope optics, onboard computers, and another major element.
We have participated together with Belgium in developing the light baffle, the long tube that you see on the telescope, which is keeping scattered light out of entering the telescope. And of course, since we are measuring very, very small light variations, this is extremely important. This is actually an unprecedented level of baffling that has been performed.
Even more powerful space telescopes are already being planned for the future, including ESA's Darwin mission. But Corot marks the first step in this new phase of space astronomy, better understanding other solar systems, how their planets are formed, and how life on them can arise.
It will start changing mankind's view of itself, the context that we see ourselves in, because it will start to find out what kind of a world we live on. Are we unique or are we not? And then, of course, the follow-up of that is to find out whether there is life somewhere else. So it's a long road that we are setting off on, but we are starting on the road, and that's what makes me so excited about this.